Hi, I'm Randy Reed, Executive Director of the National Lighting Bureau, and we're broadcasting from the studio of one of our sponsors, the International Brotherhood of Electrical Workers in Washington, D.C. We're here for the 9th Annual Lighting Forum, and I am joined by Jim Gaines of Signify, Jeremy Yon of Current, and Harold Jepson of Legrand. The name of this panel is titled Seeing UGR Clearly, a discussion about the background and application use of UGR. Gentlemen, welcome.
Thanks, sir.
Well, Jeremy, the first question goes to you, and in 9 years I've never asked this question. What is the goal of today's session?
Right. Well, thanks for having us, and we're really glad the NLB was interested in having us talk about this topic. So we're here on behalf of a NEMA technical task force, which has been looking into the topic of glare, understanding how the history of the UGR metric came about and how people can use it. And we're excited as manufacturers. The industry is very engaged in visual performance, understanding glare, how people are comfortable in spaces. But unfortunately, there's a lot of misunderstandings that are out there. And as with any tool, right, UGR is a calculation, and if you misuse a tool, you can really do more harm than good. And so what we're trying to do is we're trying to bring that awareness that we've learned to lots of people that can apply it in a better way. And then to also be able to really have unity around the idea that glare is an application consideration. And really that's why we're here to talk about.
An application, not a product.
Correct. Application, not a product.
Okay. Harold, explain a little bit about the background of UGR and tell our audience what it stands for.
All right, well, so really there's two backgrounds I want to talk to. The first one is just a realization that we were seeing a trend out there was we were getting requests for luminaires to have a specific UGR number. And really that was rolling, I think, out of performance and quality standards, where we were seeing an assignment or a request for a specific number to be assigned a luminaire. My 89-year-old father, if you ask him, he's still got a little bit of a wit about him, and if you ask him, how are you doing? He says, compared to what, right? And so that's the same thing that we're here to convey, is that with UGR, unless you understand the real context and application, that number, and I call it the fallacy of the number, you can't really utilize it properly to determine. It's a misconception and it's erroneous to use that number without the context. So the background is that it goes back, and we went in and dove into to go backward at least to look to really see what the meaning of UGR was. And so unified glare rating, right, that's the term. And it actually, the research was done back in the 50s, or started back in the 50s. We didn't actually see a standard until CIE 117 came out in the late 60s and 70s. And really it was about fluorescent troffer lights, right? Lensed fluorescent troffer lights. A lot of things have changed. And not only that, a lot of our research and understanding how people respond and how all the differences there are with human perception actually, that it's not just one number. In fact, some of the standards will be very clear, is that if you think that the right UGR for your task and application, and some of the standards try to apply what is the right maximum number to an application, but that it should be 3 steps above and below. So if you're trying to achieve for your specific application a UGR of 19, right? You should be anywhere between 17 and 21 is very acceptable. It's actually, those are imperceptible steps almost. So it's very much a range is what UGR is. And those are a lot of things that we found. And we're not really here to say that the UGR is a bad metric, right? There's some areas of it that we think have a little bit of misgivings. It could possibly be improved, but we're here to say really is that you need to use it considering everything else inside the space or the room for it to be used accurately.
So you're not here proposing any kind of new UGR method or calculation. Your point is look at the application, not at the number of the fixture.
Right, and there's a lot of good reasons to that. I won't go into that. Jim will probably talk to some of that a little bit in what he's here to talk about. He's the PhD. He's the smart guy who knows how to roll the numbers.
Well, you teed that up. So Jim, explain to our audience a little bit about some of the applications and what you've seen.
Yeah, the role of the application is essential in the value of UGR. And when I say application, I mean things like the the shape of the room, the layout of the luminaires, the reflectances of the surfaces in the space. It's not just linear, ambient, or high bay luminaire. You have to account for all that stuff from the application. So maybe the best way to look at it is with some examples, and here we have the sheet. So on this example, there are two real luminaires shown side by side, and on the left example, both of these are the tables from the CIE process. So CIE tells you how to do the tables, how to get them, and how to account for the role of the application. So the leftmost column is the shape of the room, and the rooms go from small to large, long and skinny to square, and the top row is the reflectances of the surfaces in the room, the floor, the ceiling, the walls. And so if you're doing a design and you know the shape of your room and you know your reflectances, you go, and that tells you what the UGR will be for that luminaire in that application. So the left side, you'll see that in the upper left, the UGR is about 3, and in the lower right, the UGR is 21, 22. So that's the same luminaire. The luminaire is not changing at all. You're just changing how many of them there are, the shape of the room, the reflectances, but you get this huge variation in UGR. So if you're trying to judge a single luminaire, which one of those values do you pick to judge that luminaire? Now, the one on the right...
Well, I can answer that. You pick the one that's going to give you the rebate.
You're right. Yeah, that's good point. So the table on the right, if you look at that one, all the values are close to 20 in there. There's not much variation over the table. A lot of variation over the left one, not much variation on the right. And the reason this happens, let me make one more point. You'll also notice the values on the right table are close to 20s, and the values on the left are close to 15 on average, say 10, 15. But that doesn't mean the luminaire on the right is better than the one on the left, because if you look at the amount of light from each of those, the one on the left is 3,000 lumens, the one on the right is 17,000. So if you scaled them to the same light, the one on the right would be about 15. So they're both about the same average UGR across the table. So don't think that the one on the right is better than the one on the left or the other way around. So the reason this happens is because of the beam shape of the luminaires. The one on the right has a sharp cutoff, not much low angle light. The one on the left is a mushier beam, more low angle light. And if you think about it, if you're in a large room filled with these luminaires on the right, the sharp cutoff, the ones that are far away are not sending any light to your eye. So UGR doesn't change much for a sharp cutoff, narrow beam if you change the shape of the room. Okay. So this right table, all the values are close to 20. There's not much change. It's because of that sharp cutoff. The one on the left has more low angle light, so the far away luminaires are sending some light to the observer's eye, and the UGR does depend on the shape of the room. So I'm trying to give a sort of a common sense way of seeing why they're so different. So I hope that shows you how strong the role of the application is here. You might think, well, why don't we just require everybody to use luminaires like the one on the right all the time and get rid of this variation that we're seeing in the one on the left, and everybody uses sharp cutoff lights everywhere. Now this brings us to the little table at the bottom of the larger tables, which tells you, all right, let's look at the next slide, the one with the layout of the room and the luminaires, and there's these little green squares on two sides. So those are, UGR is supposed to be an average, and that's what the larger table has, is average values in it. for an observer that's in that green square. So if you calculate individual points within that green square, you may get varying UGR across the square. So you need to average to get the final UGR. And that lower table shows you how much the UGR is changing if somebody moves around in that green square. I hope that's coming across. So again, you have to look at the application. When you're designing a room, are the people going to be moving around a lot? Or are they going to be fixed in one place? The designer needs to consider whether that variation is important or not. But let me go back to the tables. The one on the left, you see the lower table has very small numbers in it, so the UGR is quite uniform across the whole room. Even though UGR is different for different shaped rooms, it's quite uniform within a room. The one on the right is the opposite. No matter what the shape of the room, you get the same UGR, roughly. But if you look at the lower table underneath, there's big numbers there, which means as you move around, you're experiencing different glare from point to point. And this is one thing Jeremy hinted at earlier, is that you have this, as you walk across that sharp edge, the cutoff from the luminaire, you'll see you might see a flash in your eye. So exactly where you count, where you calculate, might include that flash or not include it. So that's another part of the application that plays a role, and the task that's going on in the room. So bottom line, you can't use UGR without considering the application. And that's the way CIE designed it too.
Melissa Ricketts, and she's on your NEMA committee with the Acuity brands, she's done some theoretical work comparing different UGR numbers of a few fixtures. Can you share those numbers?
Yeah, definitely. Let me take that one. So yeah, it's too bad Melissa couldn't be with us today, but what she and the committee has done is taken a look at the impacts of this if you do try and put all of this burden onto a luminaire design. So again, looking at a couple of examples, if we start with a troffer, so a 2x4 troffer, the original CIE method envisioned a lens troffer back in the a couple decades ago. But if we think about contemporary troffers, there's often a center glowy object that helps to define the way that the space feels. If you then take that and you try and shape the optics precisely to achieve a certain UGR number, like let's say UGR 16 or something like that, you have to do something to be able to get that shape out of the optics. And so maybe you'll make the lens clearer, or you'll add some facets to it. And the consequences is that sometimes you can see the LEDs, or there might be multiple images of LEDs, and so you get pixelation across the lens. The other thing that happens is you're taking that beam and you're pushing it down, right? It's that mushy versus shape beam, as Jim was talking about. And one of the things that does is it takes the light away from the walls. So the upper parts of the walls can start getting dark. Now, if you think about lighting design as a holistic practice, right? Those two elements, how uniform the lens is and how adequately the wall is shaped, are usually really important parameters. And you can see this push and pull of what happens. In another case that she was looking at, and all of us have really seen, is in linear fixtures. That's a real challenging space. It wasn't imagined by the original UGR calculations, and it's really hard optically when you have a tight line of light that you're trying to shape. And if you put precise optics on it, what can happen is you can separate the light out of the LED and you get these gold bands in the space, or your uniformities can get very hard where there's bands of dark and light, in addition to the pixelation in the dark walls. So you can see that anytime you try and do this, right, and this is true for product design anywhere, right? What product design is about, it's about taking these competing factors and then finding balance. And the balance is in context of the application space. What is that product going to be used for, and how do you balance all these things? And anytime you take one of those factors and you give it a priority, or you take that lever and you push it way forward, there have to be consequences.
Right.
And then if you think about what Jim was talking about, if you take that same luminaire and you put it in a black room, and you take that same luminaire and you put it in a white room, and you're in that space, you're going to notice a complete different experience as far as how you look at that fixture and what you think that product provides for glare or visual comfort. And we think that the difference between just that experience is probably more than any product designer can do in the luminaire itself, right? And that's the challenge for this whole thing. So that's why, our overall message through the white paper and through these types of outreach is to say, let's work together. The Luminaire is part of the environment, and this is really an application solution that we need to get to in order to address the issue.
Okay, now that's a very good discussion. Let's talk about what actually is going to happen. Okay. Do you foresee the industry changing and not using the UGR product as a number?
Well, I don't know how much. So we have to talk about what the industry is, right? So if we're talking about a specifier, a lighting designer, an architect, somebody that's trying to achieve an objective, right? UGR is in its proper deployment. So UGR is a calculation of an application understanding of the luminaires and the environment working together. That's a very appropriate way of using UGR. That's what we've defined. That's what Jim's talked about. It can be a helpful tool, just like doing the lumen method to understand what an average foot candle would be in a space. What we don't see is that we don't think about how to get a average foot candle number on a horizontal surface is the same sort of qualifying factor for a luminaire as we do a UGR value. What we need to do is we need to have UGR evolve into being used, much like the other tools that lighting designers have. From a luminaire perspective then, maybe this is where you want to go, Jim. Do you want to add more?
Yeah, one of the parameters we define is UGR Luminaire, and that's an incorrect use of UGR. It's basically taking a reference space, one of those cells in the tables I was talking about, and deciding if a luminaire is good or bad based on that one cell. So if you do that, let's say you're a designer, you want to take care of glare, you're going to pick the 4x8 room, you're going to say, okay, I'm going to judge this product based on that, and I'm going to put it in my bag of tricks forever if it passes. Okay. That's great if you're only ever going to design 4x8 rooms for the rest of your life.
When you say if it passes, if it passes what?
Okay, you by some means come up with a spec on UGR. Let's say it's 14.4 or something.
Okay.
Now you define this reference 4x8 or whatever space you're going to use. You go to the table and it says 14.5. You're going to say, this luminaire is not good, I'm not going to use it, I'm never going to use it again.
Okay.
But you've only looked at one cell, and there are lots of other cells in that table that are below your spec, your 14.4. So if you ever design a room where it's below your spec, you're not going to consider this luminaire. You've thrown this out forever. So you're losing options if you do that. And similarly, if you depict 14.6 as your limit, you would have accepted that luminaire. You'd put it in your bag of tricks forever. But if you look at the larger rooms, the UGR is above your spec there. So you've accepted this thing forever based on this one reference case, but when you design these bigger rooms, you're not going to meet your spec, and you might get complaints from your customers and stuff. So that's the big problem with UGR Luminaire, and not including the real application.
So the approach you used, if I may, was regarding the lighting designer and what they're doing. What if you are a third party and you're designing rebates from utilities? How do you use UGR appropriately to qualify whether or not a fixture should or shouldn't get a rebate?
Yeah, I think that's a challenging answer. I don't think there's an easy answer given what we know right now about glare and human perception, right? You talk to the researchers, and this is a lot that Melissa had dug into, and we mentioned a little bit about in the history. And it's a real question on whether we even understand what a human in our eye system means to glare. So the first challenge is that what are you trying to capture by requiring a UGR method? And then what you want to do is look at how that aspect can be captured in another direction, or how does it really fit into your program, right? And I think that's where we talked about the industry has to come together, right? There are lots of systems out there that attempt to help in the process of determining what a quality product is, to help in determining what satisfies a certain requirement. And I think that's what we need to do is we have to work together to kind of understand those objectives, because it all comes back to one thing, right? from a manufacturing perspective, a lighting design perspective, we're all doing the same thing. We're trying to create the best environments possible for people in those spaces. And it never helps to have someone uncomfortable in that space. That's never the objective. But then how to get to that point? Is it really a brightness question? Is it really a spectrum question? Is it really, we don't know those answers from an academic and research standpoint, so we can work together in order to try and come up with the right answer. There's no shortcuts, I think, is really what the answer is there, Randy.
Okay, Jim?
So there's really only two things you can do. You can require the person who's asking for the rebate or whatever to do the simulations for the actual application, but then that ends up being a custom rebate situation. Most people don't want that. And the only other thing you can really do is just advise the designer to consider UGR and to use it correctly. But specifying a UGR Luminaire value is trouble. Then you're like I said before, you're throwing away good options and you're accepting bad options. So if your goal is to get light quality, you're not going to do it that way.
Harold, please.
Yeah, and so they've developed over time, right? The standards have been able to develop a more simplified process, right? The tables, for instance. That gives you a lot of variability to go, look, if you can get a table for a luminaire, right, you can go through that. You don't have to necessarily do all of the simulation, if you will, or ask for that to be done. As a professional that would have to look at a full design for a simple rebate program. So there are some tools that can get you close, right? There's recommended UGR values for given tasks. So what kind of a space is it? And then you can look across the table for various space sizes to see where it fits. And you can, from that, you can get a fairly decent judgment, but you can't ignore it. You can't just go say, hey, look, this is the maximum value I'll accept, and then ask for one number from a luminaire. And that's what we're saying, right, is that you got to look at it with an application, and the table can help you get close to application because you can look at various room sizes and reflectances based on how the application is set up.
Closing comments?
You know, we're really happy to have this conversation, and we want engagement. We want people to talk about their ideas. The IES and other organizations, NEMA, we're all trying to move this topic forward. I think there's a lot of people, there's a lot of smart researchers. People understand how important this is and want to move it forward. And so that's the thing. We need to not be so urgent that we run to a shortcut, which ends up causing more harm. I think we need to just pull together to understand what are the real key pieces and bring it back to the fact that designing a holistic approach to the lighting design, it's true for any of these metrics, and we all have to find balance as opposed to really pushing on one thing.
Jim, closing comments?
The CIE is still working on glare, and they're working on a new measure that'll hopefully be improved with respect to UGR and more able to handle outdoor applications as well, because UGR is really just an indoor thing.
Closing comments, Harold?
I would say don't fall for the fallacy of the number. And so if someone's telling you that this fixture has this UGR number associated with it, and that's all the information they're giving you, right? There's an issue there, and that needs to be looked into much more than that. What kind of a space is it going into, right? What are the background reflectances? There's all these other factors that need to be taken into account. And if you look for just the number and say, I'm gonna decide based on that number, right? We're making a call that could be providing unintended glare consequences when we don't want to. We want good design for people. We want good lighting for people to be able to enjoy. It should be a comfortable environment for them. And when you look at some of the new standards that are out there really driving for buildings that provide health, better healthy or health and well-being aspects to them, right, and more productivity to that. That's what they want. And so now more than ever, we need to be conscientious of this as a design factor and how it needs to be utilized.
Okay. All right, men, thank you.
Thank you, Randy.
I have a question before we start. And one thing I want to make sure that I understand and the audience understands is, are you suggesting that we don't use UGR, or are you suggesting just don't use it in certain ways?
I think we said it a couple of times, but it certainly bears repeating that our intention is not to leave you with the impression that UGR is no good or that it shouldn't be used. the intention is to leave you with the message that you need to fully understand it, you need to understand its limitations, and use it according to its full intended use.
Okay. Understand? Anybody else want to add to that? Jim, back to you again. You had mentioned about the CIE and what they're doing. Any updates on that?
CIE has a tendency to move pretty slowly. So they're deep in the technical scientific aspects of it now. So they'll write a report eventually, and then the intention would be that it would go into application standards after that, but it's not going to be fast.
Okay. Typical, and but to the point you made, or somebody made earlier, let's do it right. Let's not do everything fast.
Yeah.
Melissa, you were not able to join us in Washington for it. I'm not trying to put you on the spot, but do you have anything that you want to add that was already discussed?
I mean, I think Jeremy did an excellent job in summarizing the challenges that we face from an engineering standpoint when you put the pressure on the luminaire to achieve a specific value. In terms of trends that I've seen in trying to accommodate for lower UGR lume values, the trends haven't been favorable. And I've seen it firsthand. I've been one of the people who have had to design luminaires to accommodate for lower UGR values. It's been a huge challenge, and frankly, from an engineering standpoint, a little bit disappointing to see the direction that some of the luminaires have gone in order to be able to achieve these lower values, from, like what Jeremy said, from more transparent lenses that begin to show pixelation, which is unfavorable, from brighter flash points at sharper angles when you start to pull down those side lobes. And so it has been very challenging from an engineering standpoint to try and put all the pressure on the luminaire in order to achieve these lower UGR values from a luminaire standpoint.
Okay, thank you. We do have a question from Jack Tully. What is your definition of a mushy luminaire? Is the cutoff more than 60 degrees?
In the IES presentation where we did this, I showed the diagrams of those two luminaires. So the mushy one has a broad distribution. It doesn't have a flat top. It's a wider distribution. The sharp one has a flat top and drops off quickly on the edges. But the best thing would be if I could send him the actual plots. I have them. So I just use mushy as a way of saying it's not flat topped, it's not sharp cut off, it's just kind of slowly changing everywhere. But it's a typical distribution.
Okay. Okay, we've got a question now from Mike. Mike Ribling, you've raised your hand?
Yes, can you hear me?
Yes.
Yeah, hi, Mike Riebling with Signify. Great webinar, thank you very much. Has there been discussion about engaging with lighting analysts, other creators of software such as Photometric Toolbox, AGI 32, to perhaps put more of an explanation, maybe a disclaimer about the use of UGR and those things that were cautioned about in this webinar so that people don't just grab that number and run with it? Thank you.
Yeah, I can take that one. So it's a good question, Mike. Not specifically, we haven't gotten that far. What I can say is that if you get a chance, there's a white paper we put together probably a year or so ago. And the funny story of that is it started as a 4 to 6 page white paper. I think it ended up over 30 pages. And those who have ever gotten an email from me will think I did that, but it wasn't actually. It was as we went around and talked to people, everyone had a little different story. And so it was interesting talking to some of the software developers, though, because that was one of the areas we spent some relatively extensive time in the white paper, is that part of the challenge of working with standards that were written back in the time when this was written is there's a lot of ambiguities because they didn't anticipate that we would have software modeling the way that we do now. And so one of the cautions that we have as well is that if you use different software, you can get different answers, and there's no way to tell which one's right because they all are taking different interpretations of the way the standard's written, which are neither right nor wrong, right? It doesn't say, it's silent in certain areas. So we have gone to that level. I think your idea of a warning or a caution is a good one. And I think I'll take that on as an action and follow back up with those people that we've already engaged with and see how they feel about that.
Yeah, and I'll follow on with that. You know, it's funny as you peel back the onion, you find all these things that you didn't expect to find. And we did have conversations in the creation of the paper that Jeremy is citing. It's a NEMA paper. It's titled LS 20001, and the good thing is that IES took a positive position behind the work that was done with it in support of it. And so, you know, its intent's not necessarily to fix the problem. It was basically let's get to the bottom of what it is and really understand how we can utilize UGR effectively. So, and there's just some dialogue in there about the software applications. But you know, great question and great insight there, Mike, about what we might be able to do to improve things.
Okay, we've got a question from Amy. Amy, your microphone has been unmuted. Go ahead, please.
Hi, thank you very much. Just a really quick question here. For application-based UGRs, like we're saying, do the calculation for your true space and account for the true layout and reflectances. Is the recommendation to use the average UGR calculated across all the different various points and view angles in that space, or the maximum? And I think it was referenced earlier what the CIE standard was. I just wasn't sure for standard specifications.
Yeah, the standard, if you saw the diagram of the room with the little green squares, you're supposed to average over those squares. That's what the CIE 117 method says to do. So that's the number that's supposed to be used. And the CIE 117 method puts that average value in the tables. So the proper values in the cells in the tabular method. The risk is that if you run the software and you get a bunch of points, a whole grid of values, you forget to do the averaging. You pick whichever number you like the best, which may be the lowest or the highest, or and then you run into big trouble. I hope that answers the question.
Thank you.
Thank you, Amy. We have an anonymous question, and the question is, are well building standards going to be changed based on these findings? Is anyone talking to those that set well building standards?
There is discussion also in the paper about standards, and that's probably what's somewhat driven. I think what we call, the UGR Luminaire independent number is the standards looking for a simplified way to be able to put in a rating system, how a lighting or how a luminaire should be judged in order to see if it performs well inside of a space. What I will tell you is that there will be, I'm doing a little promotion here, but there is a panel at Light Fair that does include well on it, specifically on the UGR topic. And so we'll be able to hear from well as the manufacturer and designer in this kind of similar discussion. It's a panel that we moderated by Nancy Clanton. So we're excited about to be able to share that. And I can say that, that at least as far as the NEMA task force is that we have had some discussions with them. We don't want to, we can't say whether there's going to be any changes or not, but there is definitely some awareness with the well standard and those of us who have worked on this.
Just add that extends to the other groups that are out there. Other people might have some other acronyms in their mind that they're thinking of. And we've tried to engage, again, back to the messaging that we have, is that this is a shared interest. And I think just like we talked about the challenges of luminaire design, the challenges of program design is equally as difficult. And so, each of those teams have audiences, they have stakeholders, they have customers, and they have intentions for how to utilize their programs. And it's important to give them the information and then see how to work that out in order to meet those customer needs the best. So I think that's the important part of that, is that, again, there's not necessarily a shortcut in any of these answers, even in the program design. But we are all in conversations to the matter that's possible in order to try and be sure that the facts behind this information is available.
One of the good things about Well is that they know the particular project. It's a project-based qualification. So they have access to all the application information you need to calculate glare properly. And they do actually have two ways of doing it. And one of them does include the full application. So, and one is the UGR Lume. So certainly we hope to have some influence on that, but we'll see.
Okay, Mary Beth Gotti, you've raised your hand. I've unmuted your mic. Go ahead, please.
Yeah, hey, thanks so much. First of all, I just wanted to thank participants for their efforts and really trying to push forward, glare metrics that work, that make sense, and how we apply light in spaces. And I had one comment, and one was that it's kind of like deja vu all over again. I mean, I think about, when lensed fixtures were being replaced with parabolic and parawedge cube louvers, and gosh, look at how it controls glare as I look across the room. But if you're sitting underneath it and someone said, boy, it's really bright, there's something like overhead glare that's causing me an issue that had nothing to do with the cutoff that we were really trying to control with some of those designs. I mean, do we just need more than one metric? I mean, really look at the application-oriented UGR, but is there another metric that perhaps when added to UGR can perhaps expand how we can predict how comfortable lighting will be in the space?
Well, I think that's maybe what we're hoping CIE will do in the future, is improve it some. Not a real satisfying answer, but.
Yeah, Mary Beth, from some of the folks we've talked to, I think what you're asking is very good, because I remember learning about overhead glare and everyone always said, we don't know why, it just is, right? And that's always an interesting problem to solve, right? And I think in general in glare, some of the opinions I've heard are that there may be something different in our visual system that triggers what we label as glare, right? There may be physiological issues, there may be other things. And honestly, what we're dealing with are equations that were designed to represent experiences in specific instances, right? In the paper, we go into a lot of examples, and others have done this as well, as far as looking at what was done in the studies, right? So a bunch of guys sat in a room in the 50s and came up with something, and everyone deems that is the way we should all do things from here till eternity, right? I don't think anyone agrees that that's the end game. The idea, though, is how do you move it forward and where do you start with? And that's why I think there's really smart academics and researchers that are working on this to try and answer some of those questions.
Great. Thank you.
Yeah, maybe I could add a little more on the CIE approach. Most glare, or all glare methods probably to this point, have been figured out by taking a bunch of people, putting them in a room and asking them, is this glary or is it not glary? And then you compile all the responses and you make some curve fit. But that's pretty limited because you're only testing a few conditions. The approach CIE is taking is to try to model the human visual system and include that rather than just doing these phenomenological approaches to getting the measures. So hopefully, as we get a good model of the human visual system in there, it'll take care of all those factors.
Jennifer Bronze, I'm going to unmute your phone or your audio. Go ahead, please.
Thanks, Randy. I think Jim might have addressed this already, but I'm just wondering, I'm seeing that office lighting has just gotten a lot more diffuse and, as he calls it, mushy or Lambertian over these many decades since I've been in the lighting business. So I'm just wondering, why is that? Is that because our computer display technology has gotten to be less sensitive to reflected glare veiling reflections? And so I'm just wondering whether these trends in office lighting mean that our UGR rates maybe don't need to be quite as stringent as they used to be when we had CRTs displaying our work. So it sounds like Jim's saying it's more about the direct glare in our eyes more than reflected glare as a concern with UGR.
Right. UGR, at least the tabular method, doesn't take care of reflections from things like CRT screens or LCD screens. It's just looking at the walls and the ceiling and that sort of thing. With full modeling, I suppose you could get down to that level. Jeremy, you want to add to that at all from your perspective?
Well, just as far as the why, I think the why is because, as you've noticed from the IES over the years and through design practices, people acknowledge the importance of vertical brightness. They acknowledge the environment and the space to be able to adapt to all of our needs as humans in those spaces. And I think that's where you've seen a lot of that shift. What's funny, I've always said that lighting design isn't in a way fashion where things are cyclical. And so if you go back in time, right, and you look at lighting back in the 60s, you look at, things were a lot more diffuse, a lot more uniform. You even had like luminous ceilings and things, all with their consequences, right? But then, yeah, if you ever gone into a space that was still around from the 80s with deep cell parabolics, where everyone was super critical about those CRTs, I think the change in the CRT allowed the changes in lighting design, right? I don't think it necessarily drove it, but I think what it enabled is people to think more about how the space should feel. And so you can get rid of that cave-like effect with the dark walls. You can try and do things like that. And today it opens up new opportunities, right? For those people that are really trying to understand, is it possible to do circadian impacts from overhead lighting and or just general lighting in general? Those require higher levels of brightness in the vertical directions, right? You look at any of the papers are out there, any of the objectives, it's all about increasing vertical illumination. So I think that just all goes to the complexity of the design. And Melissa, do you want to add some more?
Yeah, I was actually going to add something. So right before glare got big, and I would say this was around maybe the 2019 era, I was involved on a lot of office space type lighting projects that were really starting to push this idea of what we were trying to coin as volumetric lighting. And to what you said, Jeremy, to pulling that lighting up a little bit higher on the wall. So we were looking at a lot of new distributions where rather than having just your Lambertian, we were calling it volumetric because we were pulling up a little bit more light, a little higher, so that when you had your fixtures in the ceiling, instead of having, say, a foot from the top of the ceiling down the wall where you would start having your illumination, it would pull it up even higher. And this was said and predicted to be a huge new trend in lighting. And then the UGR thing happened. And we literally nixed every single push to get volumetric lighting to be a thing because we said volumetric lighting is completely counter to UGR. So instead of trying to put light up, now we've got to pull it all down. And so a lot of the work we had done looking at the benefits of, in office spaces, putting lighting much higher on the wall to add a lot more wall uniformity, that was just all completely gotten rid of. And then we just did this big push and set in the opposite direction to pull it all down. And, to your point with Lambertian lighting, it's a personal preference for myself, but I find diffuse lighting to be very pleasing and very calming. And I find, when I'm working with these fixtures to make them more UGR friendly, I find that I'm designing a fixture to do the opposite of what I personally like as a preference. So I did see that as a very interesting trend in that 2019, 2020 era.
Okay, very good. Let's go ahead and wrap up here. I want to thank our panelists for a great discussion. We want to thank the attendees for some great questions. And please do join us next Monday, 1 p.m. Eastern. Light in the day improves a hospital stay. We will have that link at the NLB website, and we will have this video posted on Monday, and we will include some of these links in the video as well. Okay, thank you all.